Hello, future teacher, and welcome to your complete guide to passing the science portion of your Praxis 5008 exam. In this video, I'm going to be covering everything that's going to make you feel totally confident to pass on exam day. Before we dive in, a quick note using our workbook, which looks just like this. Here is our study guide for this Science Praxis 5008. And if you just scroll on down just a little bit, you see this Praxis 5008 Science Workbook. Click the Open Now button. Make sure that you use this Google Doc in order to print it or put this on your tablet device, or you can just complete it right from your laptop. All of these fill in the blanks directly correspond to the presentation that I'll be providing today, and this engages your learning and heightens the ability to recall the information on exam day. So this is a great resource. I highly recommend for you to use it. And just to make things easier for you as you're filling the workbook out, for all of the terms that are used in these blanks, I have made them bold, and they look like this. This key term phrase right here is just a sample or an example to show you what the term will look like, but I'll point it out when we're going along the presentation. And if you see a word that's both highlighted with this cream color in the background and is bolded like this, you know that you should write it in the blank of the workbook. All right, now, so what is this 5008 science exam all about? Well, this is covering the core science areas, including earth and space science, life science, and physical science. And in this presentation, I'm going to be covering all of them. All right, it's also important for you to know that this lesson directly aligns with the official Praxis 5008 study companion. All right, now, what is very crucial for you to understand about the actual test questions that you'll receive when taking your real exam is that the key to passing is understanding that this Praxis 5008 exam is not just a science test, it's actually mostly a teaching test. So the majority, or 70% of the questions that you'll get on test day ask you to apply your science knowledge to realistic classroom scenarios. What does this mean? It means that in order to pass this exam, you're going to have to think like a teacher. The questions are going to ask you to choose the best experiment, identify common student mistakes, and select the right diagram or explain a certain topic. Now, in order to get you into the correct mindset, we're going to start with some practice test questions that will help you observe the types of questions that you'll see on test day. After this, we're actually going to be teaching you the content that you need to know. This is a great diagnostic practice test, so make sure that you are reading along, following along, and being an active learner. Let's begin. The way I envision this to work out is that I will read you the question, provide you with time to read answer options A, B, C, and D, and then together we will identify the correct solution. All right, number one reads, a teacher wants students to investigate the process of erosion. Which of the following activities provides the most direct hands-on model for students to observe erosion? Again, pause the video here, read all four answer options, and then push play when you're ready for the solution. Here we go. The correct response is answer option A, building a small hill of sand and slowly pouring water over it to see how the sand moves. This is the best way for the students to learn. And quick note, if on exam day you receive a question, which you more than likely will, where some of the answer options are about watching a documentary or reading a textbook or, discussing something, but one of the answer options has a hands-on activity or something that's multi-learning faceted, definitely choose or look closely into that answer option. All right, next up, question number 2. This one reads, after a lesson on physical and chemical changes, a student writes, when water boils and turns to steam, it's a chemical change because the water disappears. Which instructional move would best address this misconception? Again, pause the video, read the answer options, choose the one you think is the best. The correct response here is at the bottom is answer option D. So developing instructional moves to address student misconceptions. That's the task that's being asked. Again, that's called the task of teaching science. And this student's misconception is that substance is gone forever. Now, by showing the steam, or in this case, the gas, this can be turned back into liquid water. The teacher provides the direct evidence that the substance's chemical identity, H2O or water, never actually changed, proving to the students that, or this particular student, that it was actually a physical change. All right, next up, question number 3 asks, a teacher is preparing a unit on ecosystems. The goal is for students to understand that organisms are interdependent. Which activity best aligns with this instructional goal? Pause here, find the best answer, and then come back when you're ready. The correct option here is letter B. So the task is asking us to choose which science ideas or instructional strategies are most closely related to a particular instructional goal. This is a very common framework, then one that you can absolutely expect to see when taking your exam. Now, I chose answer option B because the food web model directly and visually represents the concept of interdependence. So similar to what we saw on the first question, which was a hands-on experience for the children, this one creates a model. So again, this keyword here of model really allows me or makes me look closely into the answer option. All right, moving on to question number 4. This one asks, a student observes a puddle of water drying on a sunny day and asks, where did the water go? Which response uses the most precise scientific language? Pause the video. Make your choice, and then come back when you're ready. All right, let's take a look. The correct response here is option A, and the teaching task that we're being asked to demonstrate our understanding for is selecting scientific language that is precise and grade appropriate. Now, answer option A correctly uses the key vocabulary and accurately describes the process without resorting to non-scientific analogies or some theory that would be hard for the student to understand. Question 5. When teaching about the solar system, a teacher uses a model where a large beach ball represents the sun and small marbles at various distances represent the planets. This model is most useful for demonstrating what? Pause the video, choose the best response, and then we will have a look at the correct response together. For question 5, I'm going with answer option D, the concept of orbital paths and the relative order of planets from the sun. Now, this question is asking us to evaluate scientific models and representations, and a key of using models, which is, the beach ball in this case and marbles, is to help our students understand strengths and limitations, and this physical model's primary strength is showing the sequence of planets and the idea that they travel in paths or orbit. So this would be another way for students to have another visual representation, and that would be an effective strategy. Question 6 asks, a student claims that plants get their food from plants get their food from the soil through their roots. This common misconception stems from a misunderstanding of which fundamental life process. Is it A, B, C, or D? For question 6, we are going with photosynthesis, and the student here is confusing nutrients and water absorbed by the roots with food, which is the energy. Remember, plants create their own energy, which is called glucose, and they do that through the process of photosynthesis, using sunlight, water, and carbon dioxide. Question number 7 asks, to test which of 3 cup materials, plastic, foam, ceramic, is the best insulator, a student proposes to pour hot water into each, seal them, and measure the water temperature after 15 minutes. To ensure a fair test, what is the most appropriate variable to control? Choose the best response. All right, for question number 7, the best is option C, the starting temperature and volume of water in each cup. Now, in this question for the teaching of science, we are asked to determine the variables for an investigation question. Now, to conduct a fair test, all variables must be kept constant. Remember, that's called controlled, except for the one that's actually being tested, which is the independent variable, which in this case is the cup material. All right, moving on to question number 8. This asks, a teacher using a spinning basketball on their finger to model the Earth's rotation. What is the most significant limitation of this model for explaining the cause of day and night? All right, for question 8, it is option B. The model does not include a light source to represent the sun and create a shadow. So the task that we are asked to complete here is to evaluate student ideas about what makes good scientific models or representations. And the concept of day and night is caused by the relationship between the spinning of Earth and the sun. So without a light source to show which part of the ball is illuminated, which would represent day, or the shadow, which would represent night, the model only demonstrates the rotation. And then, which of course would fail to explain the intended phenomenon. Question 9 asks, a teacher shows a picture of a lion's skull with large pointed canine teeth. This observation is most directly relevant to a lesson about which of the following life science concepts? Take a moment to select the answer that you think is best. Remember, we are already on question 9, and every question you go further into, you get that next step into passing. Get more exposure to different types of questions, and that is a great strategy to pass. All right, so for this question, the correct response would be option C, the relationship between an organism's structure and its function for survival. Now, the task that we are being asked for teaching science is linking science ideas to one another and to a particular activity. Now, the structure of the teeth, which as pointed out is large and pointed, that directly links to their function, which is tearing meat. And this is essential for the lion's survival as a carnivore. So we would say that this is a classic example of structure-function relationships. Question number 10, and sorry about the line here, all of these practice test questions are in the same place, and this question has 3 lines, so it just went up a little bit, but that's okay. I'll still read it to you. A student drops a bowling ball and a tennis ball from the same height and claims the bowling ball fell faster because it's heavier. Which of the following statements provides the most scientifically accurate critique of the student's explanation? Pause the video so you have enough time to read answer options A, B, C, and D, and then push play when you're ready for the correct response. Here we go. Option A is the best answer here, and the task that we're being asked about is critiquing student-generated explanations for consistency with scientific evidence. This option A addresses the famous observation by Galileo, which the heavier the object is pulled by a greater gravitational force, the greater inertia or resistance to change in motion perfectly cancels this out. So, meaning all objects in a vacuum accelerate at the same rate. Question number 11 asks, a teacher is planning a multi-day lesson on the water cycle. Which sequence of activities would be most effective for building student understanding from concrete to abstract? For question number 11, we're going to go with option B. First, starting to observe a sealed jar of water in a sunny window, then doing the modeling, and then watching the video. So, Correct option is B here, and the science instruction often moves from concrete experiences to abstract representations to provide that extra learning. Starting here with the direct observing of the phenomenon, and which is actually the hands-on observe the physical thing, the sealed jar, and then moving closer and closer to the abstract model, which would be the diagram in the second phase or second step, and then finally understanding to a large scale the abstract global patterns of weather that we see here. Question number 12. This one asks, a class is brainstorming questions for a science fair project about plants. Which of the following student questions is a testable empirical question? Read all of the options and come back when you're ready. Here we go. Question 12. The best response or question here is C. Does the color of light a plant is grown under affect how tall it grows? So the task that we're being tested upon here is evaluating investigative questions for quality. And a testable question, remember, must have variables that can be changed. Remember, we have independent variable. In this case, that'd be the color of light, and the dependent variable, which would be the height. All right, moving on to question number 13. This one asks, a student describes a battery powering a light bulb, saying the battery runs out because the bulb uses up all the electricity. How could the teacher best refine the student's language for scientific accuracy? Pause the video, read the answer options, come back when you're ready. All right, for question number 13, we're going to go with answer option A. This response corrects the misconception that energy or electricity is quote unquote used up, and it accurately reflects the law of conservation by energy through describing the process as a series of energy transformations from one to another. That's chemical to electrical to light or heat. Question number 14, this one asks, to demonstrate the concept of inherited traits, a teacher wants to use a resource that clearly shows characteristics being passed from one generation to the next. Which of the following resources would be most effective? The most effective here would be option D, a set of pictures showing a mother cat with a distinctive black and white fur pattern and her kittens. Now, the key concept here is inheritance between generations, and the picture set of the mother cat and her kitten provides direct visual evidence that we'd be looking for. Question number 15. This looks like a long one. Here we go. A class is investigating what makes an object float or sink. A student places a small pebble in water and it sinks. The student then places a large log on the water and it floats. The student concludes, heavy things sink and light things float. This conclusion is flawed because it fails to consider the concept of, is it mass, volume, temperature, or density? You got this one right, didn't you? The correct response is density. Option D, the student's conclusion is based on a common misconception. Buoyancy is not determined by the mass or weight alone, but actually also its density, which is mass per unit of volume. Question 16. We are really cooking here. Thanks so much for sticking around. This question asks, to demonstrate the conservation of mass, a teacher dissolves a spoonful of salt in a sealed jar of water and then finds the mass of jar and its contents. What is the most likely outcome of this investigation? Pause the video. Read all four answer options. Come back when you're ready. All right, let's check this out. Option C is correct. This demonstration is a classic way to show conservation of mass during a physical change. That would be the dissolving. All right, let's keep it going to question 17. During a class discussion about renewable energy, a student suggests, we should just build dams everywhere to get clean energy. Which of the following is the most constructive, science-based question the teacher could ask to promote deeper thinking? Which did you choose? That deeper thinking question comes from option A. That's an interesting idea, but what happens to the fish and the land that gets flooded behind a new dam? This question, I like this because it guides the student to consider the ecological trade offs of the things that we do to the land that we live on. All right, let's keep this going. Question 18 asks, a teacher shows students a picture of a caterpillar and, next to it, a picture of a butterfly that emerged from its chrysalis. This pair of images is most effective for introducing which big idea in science? That big idea would be living things go through distinct life cycle stages. The images of the caterpillar and the butterfly, it's a classic and powerful visual representation of metamorphosis. And this is a key example of the broader concept that organisms have distinct life cycles. All right, we have question number 19. This one asks, a student is designing an experiment to see if the texture of a ramp surface affects how fast a toy car rolls down. The student plans to use ramps covered in sandpaper, foil, and cloth. In this experiment, the texture of the ramp surface is which type of variable? All right, here we go. It is the independent variable. Remember, the independent variable is the one that the experimenter intentionally changes to see what effect it has on it. All right, question 20. We're really getting through this. Excellent job being that dedicated student. All right, next up, a young student draws a picture of the sky and explains, clouds are big puffs of cotton that float. Which of the following statements would be the most accurate and developmentally appropriate correction? Read the answer options, and then we will talk about it together. Here we go. That's a nice thought. Love the positivity starting with that. But actually, clouds are made of billions of tiny water droplets that are so light they can float in the air together. That is a really nice and simple and accurate explanation. That would be an appropriate response for an elementary student's understanding. Question 21 asks, to teach how different bird beaks are adapted for different food sources, which set of materials would provide the most effective hands-on learning experience for students? Pause the video, come back when you're ready. Question number 21, I'm going with option B, a collection of different tools and different food items. So this activity allows students to physically experience how the structure of each tool, depending on which tools and which food items the teacher selects. This is a kinesthetic, powerful, memorable way to teach the concept of adaptation. And whenever you see on test day physical things that the students play with, learn with, question, build with, kind of double click into that, look deeper into that. It's more than likely the answer. Let's keep this going. Question 22 reads, a student leaves a steel nail outside, and after a week, it is covered in reddish brown rust. The student concludes that the nail just got dirty. This conclusion indicates a fundamental misunderstanding of A, B, C, or D. Misunderstanding of the process of a chemical change. The student's explanation fails to recognize that an actual new substance was formed, which is rust. In other words, iron oxide. This is not just dirt that landed on the nail, it is the result of a chemical reaction. Moving on, question 23. a teacher uses a lamp to represent the sun and a tilted globe to represent Earth that they spin and move around the lamp to model seasons. This sounds fun. What is a common misconception this model can accidentally reinforce if not properly addressed? Or excuse me, addressed properly. Well, that would be the one all the way at the bottom, option D, that seasons are caused by the Earth getting closer to or farther from the sun during its orbit. This task is asking us to anticipate scientific language or vocabulary that might be difficult for our young learners. Remember, many teachers create an oval-shaped orbit when moving the globe, causing the globe to be physically closer to some parts of the lamp, and this can visually reinforce for our students an extremely common misconception that seasons are caused by distance, even if the teacher verbally explains this. So we have to be careful about that. Moving on, we've got question number 24, and this one reads, which of the following procedures would be the best way to conduct a controlled experiment to determine if a plant needs sunlight to live? Read the answer options. Come back once you've selected the one that you think is the best fit. Here we go. 24. Place one plant in a dark closet and an identical plant on a sunny windowsill, giving both the same amount of water. The task that we're being tasked to demonstrate our understanding of is, for science teaching, is selecting investigations or demonstrations, and effective ones. So a controlled experiment tests only one variable at a time, and this procedure correctly identifies sunlight as the independent variable while keeping all of the other important variables like water or plant type constant. So that would be great. Moving on, question number 25. Here we go. When a student plucks a guitar string, they can see it move back and forth rapidly and also hear a sound. This activity provides a direct, observable link between which two concepts? The correct response is option D, vibration and sound. This activity makes the source of the sound actually visible, and students would be able to directly see the string vibrating and then simultaneously hear the sound that it produces. Question number 26. This one asks, a class is studying magnets. Which of the following questions could be answered by conducting a simple hands-on investigation in the classroom? The correct response is option B. Now, this question is testable with simple classroom materials. Students can place a paperclip on a table, see if a magnet attracts it from underneath, and then test if various materials placed between them block the magnetic force. This can be really fun for students and a great way to learn. Question 27, you've made it to the last one. Remember, after this, we're actually going to be teaching the content. So if you felt like this was pretty tough, definitely keep watching, because that's when I'm going to actually teach the content that you need to know for your exam. Question 27 asks, a student states, a wood log and the ash left after it burns have the same amount of matter. It's just in a different form. Why is this student's explanation incomplete? The correct response is option C. The student here is attempting to apply the conservation of mass, but misunderstands that the system is open. Mass is conserved, but the student is only addressing the solid ash. The explanation is incomplete because it really ignores the mass of the smoke and gases that were created and then, poof, escaped. Here we go. Are you ready? Make sure that you have your Praxis 5008 Science Study Companion out. You're ready to go. We are going to be completing this. So without further ado, we're jumping into the study guide section of this, and this is literally where you learn the material. So without further ado, let's begin this. Here we go. We're starting with that first section. Remember, there are 3 sections here: Earth and Space Science, Life Science, Physical Science. The first one up, Earth and Space Science. Let's begin with Earth's motion. What you need to remember for test day is that rotation causes day and night, while revolution combined with Earth's tilt is what causes the seasons. Now, this is the last time that I'll bug you about this, but I just want to be clear that when you see the highlighted words in bold, these are the words to fill in on your workbook. Let's keep it going. These motions have observable effects. Shadows show change daily because of rotation, and the constellations we see at night change seasonally because of revolution. So on test day, you will likely receive a question about observing the sky and the changes throughout Earth's rotation. Here we go. Next up is all about Earth systems. The Earth is a system of interacting spheres. So remember, you're going to need to know the difference between the geosphere, the hydrosphere, the biosphere, and the atmosphere, right? And I put these in parentheses. Think of the Earth as 4 interconnected parts, and all living things in the water, on land, in air, these all have an impact with each other. Next up, there's a section on your exam all about fossils and rock layers. So remember that fossils and the layering of rock provide evidence of changes in Earth's surface and the organisms that lived long ago. Generally, deeper layers are older. Let's keep it going. Here we have weathering and erosion. Remember the difference: weathering breaks it, erosion takes it. These are 2 main processes that carve canyons, wear down mountains, and shape our landscapes. Next up is all about water distribution. Remember that it's important to know where our water is. Also, your exam could ask how much is salt water, which is 97%, how much is fresh water, which is about 3%, and keep in mind that most of the fresh water is, you're right, locked up as ice and unavailable to us at this moment. Here we go. Section 7 is all about the Earth's surface pattern. So if you look at a world map showing earthquakes and volcanoes, you'll see that they do not happen randomly. They actually occur in patterns, mostly along the edges of the giant tectonic plates that make up the Earth's crust. Sometimes this is called the Ring of Fire. Moving on, question 8 is weather and seasons. Weather is what's happening outside right now, whereas climate, and oftentimes a comprehension checking question or a question that you'll get on test day will ask you about the difference between weather and climate. And so climate is the average weather over a long period of time. The season gives us predictable changes in weather throughout the year because of Earth's tilt. Now, here we move on to climates of the world. Climates describe the typical weather conditions that you would expect in a place over many years. So, for example, you can expect Arizona to have hot, dry climate, whereas Antarctica, for example, to have a cold and polar climate. Here we go. Let's talk about living needs. This is simple but a vital concept for your exam. Remember that all living things get what they need from their environment. For example, a cactus is suited for the desert and a fish is suited for the water because that's where their needs can be met. All right, so here we have this slide. We've got natural hazards, and the Earth is a dynamic planet. There's a lot going on, right? Natural events like earthquakes and floods can change landscapes very quickly and pose significant risks to people, which is why we study and try to predict, where they are, where they're going to be, and when they're going to happen. Next up for your exam, you're going to need to know about the human impact. So remember that our actions matter. Everything that we do matters, and how we use our resources, especially energy, can change the environment. It's important to understand the difference between renewable resources and non-renewable resources. For your exam, remember that renewable resources which won't run out and non-renewable resources which can actually be depleted. All right, so Examples, renewable resources are like solar and wind, and non-renewable, as you can see on your screen, fossil fuels. Moving on, let's talk about protecting Earth. We need to teach our young learners that we need to protect the Earth, right? So good news is that science can be part of our solution. And this is part of the beauty of being a teacher. And by understanding how Earth's systems work, we can develop ways to protect our resources and reduce our negative impact on the planet. And we want to spread that message, right? All right, next up, we are moving into our second section, going from Earth and space science. You finished it. Give yourself a little pat on the back to life science. This is the study of living things. Let's get into it. First up, structures and processes. A core concept in biology is that structure determines function. So every part of an organism has a specific job that helps it to survive. Next up, life cycles. We talked about this earlier in one of the practice test questions. Remember that everything follows a basic form. It's born, it grows, it reproduces, it dies. Some, like butterflies, have a very dramatic transformation, which, as again, I mentioned the word called metamorphosis earlier, but we'll want to remember that all living things have life cycles. Next up, let's talk about survival behaviors. It's not just about body parts. Behaviors are also key to our survival, right? So parents often have instincts to protect their young, and animals may work together in groups to increase their chances of survival. Let's keep it going. Inherited traits is our topic on the screen right now. Organisms inherit traits from their parents through genes. That's why children resemble their parents. However, the environment can also influence how these traits are expressed. All right, now let's take a look at some trait variations. So look around at any group of people and you will notice variation. This diversity is crucial in the wild. Having a particular variation like thicker fur in a cold climate can be the difference between life and death. All right, next up we have ecosystem relationships. No organism lives alone. In any ecosystem, every living thing depends on each other. So think here, plants produce food, animals consume that food, and decomposers recycle nutrients from dead organisms. All right, next up, we have environmental change. When an environment changes, the life within it is also affected. So this is a major driving force of evolution, and as those best suited to the new conditions are going to be also the best suited to survive and then reproduce. Let's go on to seed dispersal. This is a part of your exam as well. Plants can't walk, right? So they need help spreading their seeds. And in case you get a test question about this, look for an answer option that uses wind in order to spread the seed. Remember, a dandelion, for example, uses the wind to rely on carrying their seeds. Also, animals help carry the seeds of plants in order to get them into new places to continue to grow. Next up, matter and energy flow. In an ecosystem, matter is recycled. So think of decomposers breaking down the dead leaves, but energy flows in one direction from the sun to plants to the animals that eat them. Moving on, we've got section 10, the sun's role. And ultimately, all life on Earth is solar powered, which is super cool. Plants capture the sun's energy through photosynthesis, forming the base of nearly every food chain. Absolutely amazing. We have completed life science. Give yourself 2 pats on the back, and let's move on to physical science, which, as you can recall, covers matter, energy, and forces. Let's get you totally prepared for test day. First up is all about the structure of matter. Everything that you see is made of tiny particles. How those particles are built and arranged gives a substance its unique properties. We can describe and identify different types of matter by observing their properties. We can measure an object's mass, volume, or observe its color and texture. Next up, this is crucial. It's vital to understand the difference between physical and chemical change. So let me help you recall this in case it's been a while. Again, this is a key distinction in physical change, like tearing a paper. it's still paper. You just have two parts of the paper. Whereas a chemical change would be like burning that paper, and then that burnt paper turns into ash and smoke, and it's just a completely different substance. All right, remember that physical change is often reversible and chemical change irreversible. Let's keep this moving. Section 4, conservation of mass. And this is a fundamental law of science. Whether you melt an ice cube or mix baking soda and vinegar, the total amount of stuff or mass you end up with is the same as what you started with. Next up, we have mixtures. Remember that when you combine substances, but they don't chemically react, you have a mixture. Think here, salt and pepper. You can always get the original ingredients back by using their physical properties in order to separate them. Here we have forces and motion. Think here, tug of war. If both teams pull with equal force, the rope doesn't move. The forces are therefore balanced. If one team pulls harder, the rope moves to one of the directions. And this would be because the forces are unbalanced. Next up, we have gravity. Gravity is the force that keeps us on the ground and holds the moon in orbit around the sun. The more mass an object has, the stronger its gravitational pull. Next up, we have friction. Friction is the force you feel when you rub your hands together. It always works against motion, and it's essential for everyday actions like walking and stopping. Next up, we have energy. Energy makes the things happen. A moving car has what's called kinetic energy, and a rock still at the top of a hill has potential energy, which is stored energy waiting to be released. Next up, we are talking about energy transfer. Energy doesn't stay put. It moves, it changes form. So when you touch a hot stove, that's thermal energy, and that's being transferred from that hot piece of metal to your fingertip or the part that you touched it. And yeah, that's heat. Moving on, let's talk about energy conservation. Just like mass, energy is conserved. The total amount of energy in a closed system always stays the same. It just changes form or just changes from one type to another. Next up, let's talk about the changes in energy. Collisions are all about energy transfer. The energy from a moving object is passed to the object that it hits, often causing a change in motion for both. All right, here we go. We are talking next about light and sound. Both light and sound are ways that energy moves through the world. They travel as waves, and the properties of those waves determine what we actually see and hear. Next up, we're going to light interaction. We see objects because light reflects off them and enters our eyes. Light can always be absorbed, which is why dark colored shirts get hotter in the sun, or it can be bent, which is called refraction. All right, here we go. Simple machines. These do not reduce the total amount of work you have to do, but in fact, they can actually make it much easier by reducing the amount of force that you need to apply in order to do the thing that you wanted to do. Quick note on that. This can be, the test takers never try to trick you, but this can definitely be one that you can overlook. Just remember, simple machines don't reduce the amount of total work that needs to be done, but they can reduce the amount of force needed to apply to get the work done. All right, you have completed the entire presentation. You are all ready. You have watched this video presentation. You finished the workbook. Go ahead and read the study guide and take the practice test at the very bottom of this page, and you will be absolutely ready for your Praxis 5008 science section. I'm wishing you all the best. Thanks again for watching.